Assalamualaikum and hi guys, this is the last video for chapter 1. In this video, you are going to look at two learning outcome, which is the first one is define limiting reactant and percentage yield. And the second one is perform stoichiometric calculations using mole concept including limiting reactant and percentage yield. Let's start by learning what is limiting reactant and excess reactant. Limiting reactant is the reactant, okay, we are focusing on the reactant side that is completely consumed in a chemical reaction and limits the amount of the product formed. That means at the end of the reaction, the reactant that we call as limiting reactant, dia akan habis. Tiada baki. 100% become a product. How many product form? Berapa banyak yang dia ada? Itulah berapa banyak jumlah produk yang akan terhasil. On the other hand, the excess reactant is the reactant that is not completely consumed in a chemical reaction and remains at the end of the reaction. That means selepas berlaku tindak balas, reactant yang we call it as excess reactant, dia akan ada baki lagi. This is the analogy to show what is limiting and excess reactant. For example, kita ada cheeseburger. Okay, sangat tidak menyelerakan. Tidak berkhasiat juga sebab tak ada sayur. A simple cheeseburger. To make one cheeseburger, we need one patty. Okay, ada satu patty, one bun and a sliced cheese. My question is, how many cheeseburger can you make jika you ada bahan banyak ni? You can only make 2 cheeseburger because you only has 2 piece of sliced cheese. That mean sliced cheese ini adalah limiting reactant. And these two are excess reactant because penghasilan berapa banyak based on the definition, berapa banyak burger yang kita boleh hasilkan adalah merujuk kepada berapa banyak limiting reactant yang kita ada. Tu untuk bagi you faham lah beza excess and also limiting reactant. Okay, dan dia kata by definition limiting reactant dia akan completely consume. Maksudnya siap 2 burger, kita tak akan ada baki sliced cheese. Tapi excess reactant, when the reaction end, you akan ada remaining reactant. So we call as excess reactant. Macam ni lah. Nanti bun akan tinggal 1. Okay. Patty akan tinggal lagi 4. Sebab dua dah guna kan, so ada baki 4. So that's why they are excess reactant. Dan juga limiting reactant ni akan menentukan how much burger yang akan terhasil, which is 2 in this case. So let's go to the percentage yield. The ratio of the actual yield to the theoretical yield multiplied by 100%. You must know what is yield. Yield, kalau kita macam direct translate, adalah hasil. That means percentage yield is referring to the product side. This is the formula. Theoretical yield is the calculated amount of product that will be obtained if the reaction is completed. Daripada balance equation, you buat perbandingan, or we call it as you buat stoichiometry, which is perbandingan ratio mole. Kemudian produk dia dapat berapa? Okay, that product we call it as theoretical yield. Actual yield is the amount of product that obtained from experiment. Actually tu apa yang sebenarnya yang sepatutnya didapat. Theoretical you dapat daripada apa yang you kira. Selalunya soalan, the question will give you the actual yield. For theoretical yield adalah yield yang bila you calculate, you buat perbandingan reactant dengan produk, nilai produk yang you dapat tu we call as theoretical yield. To check your answer, you punya actual yield must be smaller than theoretical yield. This is the analogy to understand what is actual and theoretical yield. There are 6 shirts and 4 pants. Okay, ada 6 shirt, 4 pants. Abaikan X ni dulu lah. We can realize that the pants are limiting reagent and you can make 4 outfit of shirts and pants. Okay, so based on this set, you dapat tahu the limiting reactant is the pants. Sebab pants ada 4, shirt ada 6. So total you boleh buat 4 outfit. 4 outfit itu we call as theoretical yield. Benda ni berdasarkan perkiraan lah. Ini ada 4, ini ada 6. Okay, ikut perkiraan sepatutnya boleh buat 4. So that one is theoretical yield. Turns out, okay, one pair of pants have a tear in it, so they are not able to be worn. Okay, turns out sebenarnya satu seluar ni ada koyak. So bila ada koyak, dia dah jadi defect item. So awak tak boleh nak matchkan dia dengan baju. Turns out sebenarnya the pants that you can pair with the shirt, there are only 3, and turns out that you hanya boleh buat 3 outfit sahaja. So 3 outfit yang sebenarnya awak boleh buat adalah we call it as actual yield. So now I would like to ask you to calculate the percentage yield untuk this analogy. Based on the formula of percentage yield, what you have to do, you just substitute the values. Okay. Actual yield 3, yang sebenarnya yang boleh dihasilkan adalah 3. Theoretical yield berdasarkan perkiraan, berdasarkan compare macam ni, boleh buat 4. So 3 outfit divided by 4 times 100%. The percentage yield for this analogy, you get 75%. I hope both analogy yang burger dengan shirt pants ni bagi out nampak overview, okay, what is limiting return, excess return, theoretical yield, dan apa itu actual yield. Let's do this exercise together. Read the question first. Metal aluminium react with sulfuric acid to produce aluminium sulfate and hydrogen gas. If 10 gram of aluminium is reacted with 60 gram of sulfuric acid, 57 gram of aluminium sulfate are produced. Determine the limiting reactant and percentage yield of the reaction. There are 2 things that the question asks: limiting reactant and percentage yield. So let's start dengan kita cari dulu limiting reactant. So first kali what you have to do, if you have to write balanced chemical equation. Kita buat bersama-sama. Madam tulis, you pun tulis. Kita ada aluminium react dengan H2SO4. Dia akan jadi, dia dah bagi tahu dah the product is aluminium sulfate and hydrogen gas. You have to make sure the chemical that you write is balanced. If not, balancekan dia. So kita letak 2 depan aluminium, 3. Okay, kat macam ni kita settlekan metal dulu. Sebab tu saya start dengan aluminium, kemudian sulfur, kemudian barulah non-metal which is hydrogen gas. Hydrogen gas ada 6, so 3 kat sini. That's why it's very important untuk you practice balance the chemical equation. Practice, jangan sampai cuai lah, sayang. Okay, so this one like basic that you learn at school, kita just gunakan balik saja. And then the question gave you this one 10 gram, this one 60 gram. The question gave you mass for both reactant. So bila you nak cari produk, awak kena figure out reactant mana adalah limiting reactant sebenarnya. Okay, aluminium of sulfuric acid. You cari dulu mol kepada aluminium. 10 gram divide molar mass of aluminium 27 gram per mol. 0.3704 mol. The mole that you get is available mole. Mole yang ada diberi dalam soalan. Kemudian calculate the mole for 60 gram of sulfuric acid pula. 60 gram divided by 98.1 gram per mole. Then you will get 0.6116 mole. This is, we call it as available mole. Mole yang available dalam soalan. Then you make a stoichiometry. Stoichiometry means you compare the mole ratio based on the balanced chemical equation. So this is the balanced chemical equation. Stoichiometry tu, that means you balance mana-mana ratio lah. In this case, you kena buat stoichiometry between these 2 reactants. Sebab you nak identify which one is the limiting reactant. You compare. You buat stoichiometry between these 2 reactants. Based on balanced chemical equation, 2 mole aluminium will react with, you buat 3 line, present equivalent to 3 mole H2SO4. Alright, sekarang you ambil mana-mana available mole sahaja. Okay, contoh madam nak gunakan available mole yang ada pada aluminium. So if I have 0.3704 mole aluminium, berapa sebenarnya mole H2SO4 yang akan terhasil? How to get this one? Automatically it's darab silang. What I mean by darab silang, contoh ini, contoh this one, you letak unknown X. Okay, so you buatlah darab silang. Okay, maksudnya ni 2X sama dengan 3 darab 0.3704. Then you selesaikan what is X. Alright, so dia datang daripada darat silang. Then you will get the X lah, which is mole H2SO4 yang kita nak. But since madam nak cepat, dan I already understand that one, okay, how to get this tanda soal. Okay, madam tak tunjuk lah cara darab silang itu. It's okay sebab that one just only matematik sahaja dan dia tak ada markah pun untuk tadi matematik punya step tu. Yang penting you dapat mole yang betul. The marks will be given for the correct mole of H2SO4 here. Okay, jalan kira tadi tak ada. That's why madam men-shortcutkan dia. Okay, but if you don't understand how to get this question mark ni, okay, mole H2SO4 ni, you tunjuk je lah darab silang just in case takut you cuai. Bawah bahagi atas darab tepi, dapat sebelah dia. Kalau you tak faham, tunjuk darab silang sahaja. Then I will get 0.5556 mole of H2SO4. Mole H2SO4 yang you baru dapat ini adalah mole needed, mole yang diperlukan. Here, as you can see, you ada 2 mole H2SO4. Mole needed H2SO4 and mole available H2SO4. Bila you ada 2 jenis mole yang berbeza, then you compare untuk you identify H2SO4 ni limiting or excess. Boleh tak madam, saya nak cari needed AL, saya nak compare, saya nak cari AL ni apa? Available ke excess? Yes, boleh. Maksudnya, awak ambil available H2SO4 letak sini dan awak cari needed aluminium. Then you compare needed aluminium, which is kita tak tahu berapa nilai dia, dengan available aluminium to determine aluminium ni excess or limiting. Dalam perkiraan madam, since madam dapat needed and available H2SO4, madam tengah nak tahu H2SO4 ni limiting or excess. How to determine? So kat sini you tahu mole H2SO4 available is larger than mole H2SO4 needed. So H2SO4 is a reactant, tapi mole yang ada lagi banyak daripada mole yang diperlukan. So what do you think H2SO4 is? Limiting reactant ke excess reactant? Oleh kerana mole yang H2SO4 ni available ada, okay, adalah lagi banyak daripada yang diperlukan. That's mean H2SO4 is excess reactant. Thus, aluminium is limiting reactant. Settle. The first question, this is how you determine which reactant is limiting or excess reactant. Again, madam recap. First kali, you have to write balanced chemical equation. If the question already gave you the equation, you have to check the equation whether they are balanced or not. If not, balance the equation. Then, you have to find the mole for both reactants. Dan mole yang you dapat daripada mass given in the question, we assign it as available mole. Mole yang ada. Mole yang reactant tu ada. Okay, then stoichiometrically, secara stoichiometry, you compare mole between two reactants. Okay, dah dapat yang ni, kemudian you decide awak nak cari needed yang siapa? Awak nak cari needed yang aluminium, nak tentukan aluminium ke, ataupun awak nak cari needed kepada H2SO4? Terpulang pada you. Okay, in my case, saya nak cari needed H2SO4. Maksudnya saya nak tentukan H2SO4 ni limiting or excess. Once saya dah tahu, so lagi satu tu kita akan tahulah automatic dia adalah apa. So I want to find the needed for H2SO4. So what I have to do is I take the mole aluminium yang available, I'm comparing stoichiometrically, then I will get the mole for H2SO4, which is 0.5556 mole, and that new mole of H2SO4 adalah mole that we assign as mole needed, mole yang sebenarnya diperlukan. Then you will have two different mole of H2SO4, available yang ada and needed yang diperlukan. Then I'm comparing mole H2SO4 available with mole H2SO4 needed. Mole H2SO4 available yang ada is larger compared to yang diperlukan. Kita ada banyak sangat. Tapi kita perlukan sikit. Itu bermaksud H2SO4 ini adalah excess reactant. Once you identify the excess reactants, automatically you will know the other reactant is limiting reactant. Cuba fahamkan, practice. Jika tidak faham, please ask me. So now we will calculate the percentage yield. So the first thing that you have to do is you have to write the formula for percentage yield. The mass given in the question is actual yield. Since the mass of product given in the question is aluminium sulfate, that's mean the percentage yield yang soalan tanya is referring to the aluminium sulfate, bukan hydrogen gas. Okay. T7 is actual yield. So now what you have to do is you have to find theoretical yield. And bila you tengok slide tadi, theoretical yield adalah yield yang you dapat daripada calculation, daripada balance chemical equation secara stoichiometrically. You compare the limiting reactant with the product yang kita nak cari dia punya theoretical yield. In this case, you compare limiting reactant tadi dah jumpa, 2 mol aluminium is equivalent to 1 mol aluminium sulfate. Then you compare mol aluminium available tadi dari yang datang daripada 10 gram aluminium, 0.3704 mol aluminium, you akan dapat berapa? So you bahagi atas darab tepi, you get is 0.1852 mol aluminium sulfate. Sepenuh mana madam tulis ini, seperti itu jugalah awak kena tulis semasa you jawab soalan ni. Same goes to the tutorial. Tulis lengkap. Okay, jangan nak ringkas-ringkas ni. Ini paling ringkas madam ajar ni. So, you dah dapat mol. Then, since yield dia dalam unit gram, that's mean you have to find the theoretical yield dia dalam unit gram, which is you dapatkan mass kepada aluminium sulfate ini. So to get the mass aluminium sulfate, mol yang you baru dapat, you multiply with the molar mass. Okay, so the molar mass is 342.3 gram per mole. Kalau madam ada salah in my calculation, please inform me. Okay, ASAP. And the mass that you will get is 63.39 gram. The mass that you get is theoretical yield. Mass that you get stoichiometrically, you dapat daripada perbandingan mol. Okay, so you dah get the theoretical yield. Macam tadi dekat slide ada cara untuk check. Okay, to check whether you punya theoretical ni betul ke tak, actual yield, the value of actual yield will be smaller than theoretical yield. Okay, actual 57, theoretical 63. So ada kemungkinan besar theoretical awak ni betul sebab dia lagi besar daripada actual. Then you substitute the value into the formula, we'll get the answer. Percentage yield. Okay, formula dah tulis kat atas, so tinggal substitute sahaja. Actual is 57 gram divided by 63.39 gram times 100%. You will get 89.9%. Boleh tak nak tulis 90? Boleh, tak masalah. So this is the percentage yield for aluminium sulfate. Madam concludekan this part. Okay, untuk percentage yield, okay, to get the percentage yield, you refer to the formula. Okay, the mass given in the question, we call it as actual yield. So yang atas. Then you have to find the theoretical yield. To find the theoretical yield, you can get it stoichiometrically, which is you comparing the limiting reactant with the yield yang kita nak cari. That's why it's very important for you to identify which reactant is the limiting reactant. In this case, aluminium is the limiting reactant. You compare with aluminium sulfate. Okay, and then you ambil mole needed tadi. Okay, mole ni you dapat daripada 10 gram of aluminium. Okay, you dapat, you compare, then you will get the new mole for aluminium sulfate, and then you get the mass. The mass that you got is theoretical yield. Once you dapat theoretical yield, you check. Okay, because the value of actual yield must be smaller than theoretical. Okay, nampak seperti logik. Okay, kemudian you masukkan dalam formula, tekan calculator, dan you will get the answer. That's it for this video. Bye.